do a little bit of streaming this evening. I got a little fed up with my bot. So the bot that I'm working on is, I'm talking to nobody, but I'm recording, so this will be on YouTube. The bot I created, it's okay. I added some tiebreakers, and it still loses all the time. There's some bugs in the quiescent search, I think. I'm not sure. I don't really trust quiescent search anymore. I think it's kind of like a flawed idea. So what I was thinking I was going to do today is start looking at how to set up a reinforcement learning agent. So what that means is this is like these are like the newest types of engines. So they're engines that don't just try to search ahead, but they have like sort of a self-taught notion of the value of a position. And it's self-taught by self-play, right? So the agent plays itself, and it sort of improves. It plays itself, and when it wins, it sort of improves, or whether it wins or loses, it improves its own knowledge about how good a position is. So I want to do that. I'm going to make it. Here's what I'll do. The way I can set this up is I'm going to make a new engine. So I'm going to start completely from scratch. So I'm just going to take. I'm not even going to use this stuff because I don't want to do it. I'll leave it open because I'm going to use some of it. I'm going to reuse some of the ideas. But all I need, I'm going to make the simplest possible engine that just scores a position and just picks the maximum scoring move, or the move that leads to the best scoring position. And actually, I'll do that. But I actually kind of would prefer. Well, we'll see. I haven't bet on a different idea, which is actually that we'll... Actually, you know what? Maybe it'll be easier to just copy this whole thing. I'm going to make a new file. New Python file. And my goals... I don't... As usual, I don't have that much time, but I'm hoping to have this up and running. Well, here's what I'm going to do. I'm going to have it set up so that it can learn a simple thing, which is just going to be material value. I'm going to start with no information. I'm going to have it play itself until it learns which pieces, how much each piece is worth. I'm going to fix the pawns to be worth 1. And if this thing works, it's going to learn the classical material values or something approximate to it. Like we might see something cool, like maybe bishops are worth slightly more. Some of you might know those rules. Let's call this a learn. No, let's call it RL engine. How do you? No, I don't like using RL. Let's call it learning engine. Okay. So we're gonna do paste the whole class. We're gonna get from strategies import minimal engine. We're going to import chess. We're going to import NumPy. This is the first time we're going to use NumPy. I'm going to start with NumPy for this version. I think as we get along, I'm going to use some more advanced machine learning frameworks like PyTorch or JAX. I really want to learn JAX, so this is maybe an excuse for me to actually do something productive. As I mentioned earlier in some of my earlier streams, this is just a hobby project. Definitely not getting any credit for this or anything, and I don't expect to make any money off of it, so I'm just doing this for fun. So one thing I can do to make it worth my time more than just relaxation is to also learn something like JAX or some of the newer machine learning software tools out there. Okay, so import. What am I importing? NumPy. Let's use that. Let's use NP. That's pretty standard. I need to install NumPy. I guess a simple way to do that is this thing. Okay, let's install it. At some point I'll need other libraries as well, but let's start with just that. Is it working? Yeah, it's working. Okay. So we have the initialization, the constructor. I'm going to get rid of all this stuff. We just need name. We don't need max depth. I'm not going to have any depth. I'm just going to look for scores. Let's say, I'm going to say, we'll do weights, and we'll do none. I'm gonna do a little. I'm gonna try to. I'm gonna do some hacking. So I'm gonna do some stuff in my head that might not work out later on. This is like not great design, but let's try it. So I'm gonna say null board, or just like default blank board. No, starting board. Board equals chess dot board. So I'm just getting a starting chessboard, and I'm gonna get the score function. Oh shoot, I don't want to call it score engine. I'm gonna call it learning engine. Learning engine. And I'm going to say, so we get a starting board. Oh, right. I want to say equals self dot okay, let's call it. So a lot of machine learning code looks like this, where people put X, you call it X, like the input. I don't love it because it's hard to say what that is, but let's just do that for now. I really don't like when people code like that. So I'm going to say descriptor. So self.features and starting board. Okay. Oh, you know what? This is only going to be if weights are none. If weights is none. Actually, let's just do if. You know, I got to do that. If weights is none, then we'll do this. So I'm going to initialize weights, and I'm going to say else weights self.weights equals weights. So the weights are going to be the scores. So the way this is set up is the descriptor is going to be some vector, a NumPy vector of numbers describing the board, and the weights are going to multiply by that to give us the overall score for the position. And I'm going to have to hack in that the pawns are always worth 1. That'll be a little tricky. But anyway, that's fine. I'll deal with it. Okay, so... right. Okay, so I wanted to say weight. Okay. Let's say self.weights equals numpy. Oops, numpy dot random. So I'm just saying random weights. They're gonna be allowed to be negative because that's how I'm gonna score things. Random, and then I need to give it a size, and so that'll be descriptor.size. Okay, so everything here has been okay. Wait, it's happy except okay. Now I want to get rid of all this stuff. I don't have a cache score. I'm not gonna have. This is all cache stuff that I was using from the previous version. The get all moves I think is still necessary, so I'm gonna keep that. See, maybe I should subclass this, but I don't think I want to. I think it's going to be so different from the other engine I wrote. Like quiescent search, we're not going to use that. Negamax, we're not going to use that. I think we're just going to use search. Yeah, here's search. Okay, so keep that. So search is going to find the game. It's not find the position. So this text won't even make any sense anymore. So I'm not going to store the current position. I'm not going to do it any time because it's just going to be pretty much instant. No deadline stuff, none of this, no depth, and it's just going to be this. It's going to be, so I'll get the best moves, I'll make all the moves. Okay, wait, so I'm missing something. Actually, you know what? I don't even like this. So I'm going to generate children from legal moves. Okay, so this is fine. Get all moves, generate children from, and then I'm sorting them, but I don't care about sorting them. I'm going to simplify this all the way down. So all I need is, okay, get rid of this. So we're going to say moves equals board.legal moves. And oh, I have this infinity thing, which I did for convenience. This is an annoying thing about Python style. That's not right. From math import in. So in Python standard style, you're supposed to use all caps for constants, but now this is complaining because in the math package, in the infinity constant is a lowercase. So I could just do this. Okay, let's just do that. All right, so now instead of writing it in all caps, I'll do that. All right, I don't actually think I need to even do this stuff. All right, so I'm gonna remove this. Here's the thing. I want to do is I want to score all the moves, and then I'm gonna sample randomly from the moves based on like a manipulation of the scores to turn them into probabilities. So a higher score will be a higher probability, and this is a pretty standard trick in reinforcement learning or in machine learning. So I'm going to say scores equals, is this a list? Let's make this a list. So that way we have them in order. So we're going to make it a score. That's going to be a mp.zeros, length of moves. And we're just going to say for I move moves. Enumerate. Okay, so we're going to we make the move, and then we compute the score, and we don't do any of this stuff. We're going to do something else. So actually, I'm going to cut out everything because this is all different. I want to keep this. I want to keep. Okay, so here I'm gonna, let's clean this up. I'm gonna say calculate score, which is just gonna be descriptor equals self.features, which again doesn't exist yet, so this is gonna complain. Oh, you know what? Is this done? This looks like it's done. I can hide this. Let's say I'm gonna return sampled move. So I'm just jumping ahead. I apologize for going out of order. All right, self features, that new board, and then I'm gonna. Oh, I'm making a copy. I don't want to do that. So let's just actually do board.push, and then board.pop. Right, so now we remove it. This is just going to be board, and we have descriptor is going to be so scores I will be equal to self dot whoops, that's not useful, self dot weights dot descriptor. All right, so this is a simple scoring function. Hi, Sad Che, your name is cut off in my chat interface, so I can't see the rest of your username. Okay, so yeah, so what I'm doing right now is I'm setting up a basic reinforcement learning engine that'll be all I wanted to do is learn like basic material counts in material values, but to do it from scratch, right? Not without me telling it how much a bishop is worth. I wanted to figure out how much a bishop is worth, and then eventually we'll be able to modify that and make it think about more complex concepts. And I'm not going to do real reinforcement learning. I'll do something that's fake. It's not exactly that. Okay, so this engine, right? This engine, if it has good weights, it should work pretty well. If it has good descriptors, so it doesn't have features yet. So oops. I guess I want to do def features, and it gets a board, and I'll just give some documentation. Returns a vector describing a numerical vector describing the board position. Okay, Do I play chess? I play chess for fun. I'm average on Lichess or online. I've never played seriously in person. I played for fun with my friends and all that in school and all that. But yeah, chess is a hobby of mine. So then this is my hobby project. Trying to combine, like, I do computer science for, I teach computer science, and I do research in computer science. So chess programming is like a way of combining the two ideas. Yeah, I really love it. It's great. I think it's so cool how much history chess has, which is why I like it so much. Okay, so prestigious computer science. Yeah, it's a good field to be in these days. Maybe not so much. Well, I guess even it was always good when I was starting out. But I do artificial intelligence research, and I got into that before it got super lucrative. So now I'm training all these students who go out and make a lot more money than I do. But that's kind of fun. Okay, so all right. Let's see. What am I doing? Okay, so right. So I'm just going to count up the pieces and put those into a vector. So I'm going to create a vector that's length. I don't even care what the length is. All right, so I'm going to say pawns. So let's count the pieces. So now I have to remember how I did that with the other code. So we had done this in previous version of an engine. So I got the pieces here, all the values. I guess maybe what we'll do is I can just copy this and use it. Where am I? This one. So we get all the pieces, and now we're going to count up. Let's just consider the difference in the counts of each piece. So let's say pawns is equal to 0, bishops, let's do knights, equal to 0, bishops, 0, rooks, 0, queens, equal to 0. So, and then, did I miss anything? No, okay. So value is equal to, so I'm not going to use value here. Instead, I'm just going to say, what's a good way for me to do this? I guess kind of an ugly way to do this is okay, so let's do this. All right, so value is equal to 1 if piece color is equal to order.turn, else -1. All right, so the pieces for the player to move are going to be, oh, I want to do -1. Just I prefer it to be that the pieces for the player who just moved are worth +1 and the other ones are worth -1. All right, now I'm going to say, let's just do it this way. So if piece dot type, piece type, let's try that. Is that how I did it? Piece type, yeah. Equals chess dot pawn, then pawns plus equals value. There must be a cleaner way to do this. All right, I'm just gonna do this ugly way until no, I don't. Okay, I have a better idea. I'm going to make this a dictionary. All right, chess pawn is going to be 0. The Oh, you know what? There's a way to do this as an enumeration. This is fine. Okay, chess.knight is 1. Chess.bishop is 2. Chess. These are not piece values. These are just indices in an array I'm going to make. Queens is 4. I'm not doing a piece value for the king because, oh, interesting. I had to score the score checkmate. So I'm going to say, yeah, I'm going to say if board.is checkmate, no, checkmate, then we'll add. All right, so hold on. I'm missing a piece here. I have to make it an array. Features equals numpy dot zeros. So there's 5 piece types and then checkmate. So there's gonna be 6 different values, and then what I'll do is I'll just say features index piece type plus equals value, and then features, so 0 1 2 3 4 5 equals 1. All right, so now I'll just return features. Okay, so what this whole function does, it just describes the board. It describes the position, and it describes it in a really simple way, right? This is like the beginner way to do it, where you just count up the material and you check and you see if you have a checkmate. I could also add things like whether you're in check, whether there's a pin. There's all these things you can add. I don't want to do that yet. Eventually we'll do that, but in fact, the most sophisticated chess engines don't do that, right? They just say describe the board and then let the AI figure out how to think about the board. You know, it doesn't even say like whether what it means for a piece to be attacked or anything like that. It just says here's, like, that's why Alpha Zero is called Alpha Zero. They started from 0. They started from no knowledge, just the basic rules of what pieces are allowed to move, and then they had the AI figure it out. So we're going to try to do that as well. Eventually, if I finish what I want to do today, it will maybe be able to learn to do what's the word? To value the pieces. All right. So the pawn is the first entry, so I'm going to force that to always be 1. But in the meantime, I'm not doing any learning yet. So far, yeah. So the last pieces I had to sample a move from scores, which I had to just look up how to do that. I don't know if there's a way to do that off the top of, let's see, NumPy sample from probabilities, random choice. Nice. So there's a random choice. You give it an array, and it'll return what? An index, samples, generated random samples, single item or ND array. So if it's an ND array, a random sample generated from its elements. That's not what I want, because I don't want a random choice that's just randomly chosen from the list. I want a choice weighted by the multinomial, this one. Okay, so you give it n, you give it p-values. So n is the number of experiments. I only want 1, so I'm just going to give it the p-values, and then it'll return int size, output shape. None. Okay, I can leave that out. So it's just going to return a single number, I think. So let's call it I. Let's call it j is equal to np dot random dot multinomial. N is going to be 1. Probabilities, and I didn't make the probabilities yet. So probs will be np dot x scores divided by probs. Okay, so all I did was I exponentiated the scores and then I normalized them so they sum to 1, so that performs a valid probability distribution. So I'm basically rolling a die over all the different possible moves where the die is weighted by whatever the scores are. So what we should learn is a model that will, I mean, if this, if learning works, then it would try to generate it would try to put high probability over good moves. So sample move equals moves j. All right, this is function. I mean, it's not functioning. This should work. Why is this complaining? Features. It may be static. Yep, it is static. Okay, so I will. I'm not sure what the best software design is for that, but the one way to get rid of that warning is to just call it a static method. So that just means it doesn't have any class information. It just this could have been outside of the class. All right, so let's talk about learning. So with the learning engine, we have to basically penalize a chess engine for winning or losing. Sorry, penalizing it for losing, reward it for winning. And when it's rewarded for winning, it should then sort of be more confident in the scores that it used during that game. And when it loses a game, we should make it become less confident in its scores. So one way to do this is to just I'm going to do a really simple thing, which is not proper reinforcement learning. So that's why in my description I wrote that I'm doing faking reinforcement learning. Later I'll do real reinforcement learning, but it takes a little bit more stuff to do that. So instead I'm just going to look at I'm going to set it up so it plays a game, and then I'm going to put this in a main method. I always forget the command for that. It's like here. So maybe what I'll do first is, you know what? I'm gonna just see if this engine runs. So I guess one way I can do that is I could put it up on Lee Chess right now and play against a random mover. It would be terrible, but hi, Gwep. I'm sorry. I was just telling another reviewer that you did Minimax first, now ML. Yeah, I did Minimax and I got really frustrated with debugging recursion. So now I'm just trying to do a simple learning agent. Sorry, I called you Gwep because I can't my chat. I have my streaming set up so it cuts off usernames. So I can't see. Maybe I can adjust this. That just made it bigger. It's still cutting off your username. Okay. I apologize for only being able to see the first 6 letters of your username. Yeah. So I'm trying to do a simple learning method. But yeah, all right. So let's set this up. So I'm going to say engine equals, what do I call this thing? Learning engine. I don't think I had to give it some stuff. Oh, right. There's some stuff that the Lee Chess interface requires. It's like I give it some empty stuff and then standard error as where it's going to output, which I could change if I wanted to put that into a log file or something. All right. Where are we now? Let's give it a, let's see what happens. Let's say move. Let's just give it a new game. Okay, so it's going to make an opening move. Let's see what it is. This is annoying. The move comes out by default in UCI notation, which is Universal Chess Interface, I think. Which is it's not the interface. I mean, it just tells you the square a piece comes from and the square it ends up in, which is okay. But it's a little bit nicer to move it to do standard algebraic notation, which you can do with, let's see, I think board.san. Oops. All right, let's try running this. Why is this complaining? This is okay. Run. Okay, so there's a bug. Let's see. Features missing one required positional argument board. Starting board. Self features. Ah, I just don't need self anymore. Since it's static. Shadows board. That should be okay. Okay, there was an error, so it went to it tried to do 6 and 6 didn't like 6. Piece type, index piece type. Oh, right, of course. That's annoying. All right, you know what? Let's give the king a value. It's silly. I mean, let's be silly, but I mean, you know, there should be no piece value for the king. It's worth infinity, but it's fine. I played Maya 1 bot and Lichess a lot. Yeah, Maya's great. It's yeah, super cool what they did there. And I think it's gotten better. I think when it first started out, it did play some. I think one of the weird things about Maya, I remember at the beginning when they first released it, it would kind of play like the average move that most people would play in positions, which made it a lot better than it should have been. But then I think more recently it started playing more human like at the sort of level that it's supposed to be at, which is my level. Like I think Maya 1 is supposed to be around 15. Is supposed to be around average, and I'm basically. Sometimes I get up to 1600, then I get tilted, and I'm back down to 1500. Okay, so now I want to go to 6, and I'm going to make it a length 7 vector. So there's pawn, knight, bishop, rook, queen, king, and then checkmate. Okay, so the 7. Okay, so it didn't. All right, I had to give it all this other stuff. So I had to give it a time limit. Oh, I had to give it a board. I didn't even give it a board. So board and then time limit. It doesn't matter. This will take very little time. I think it's supposed to be in milliseconds. So I'll give it a second. And what's the last thing? Oh, ponder. I'll just leave that on. I'm not going to use ponder. All right, legal move generator object is not callable. That's because it's not. Oh, that's not a method. I see. Okay, only integer scalar arrays can be converted to a scalar index. What is J then? Let's debug this. So J came out as an array. I see. I didn't understand that. I didn't realize it would return like that. So it returns an array of the same size as the input. Of shape size. A single value is returned. Output shape. The default is none. I don't know. I thought it was going to output one sample. Each entry is an n-dimensional value drawn from the distribution. It should be of size n. An n, capital N. Capital N. That's weird. The documentation says that it's going to be a size n, but there is no capital N. Do they mean this little n? So then the little n is here. It's the number of experiments, which I thought was 1. So why did this complain? All right, let's experiment with this. So I'm going to do npr random multinomial. Let's do like 2 n probs. The size is 20. Probs is length 20. So there's 20 legal moves. The output was size 20. It wasn't affected by. It wasn't affected by when I changed it to 2. So what are the values here? What do I look at the values? That's not. Oh shoot. Wait. What does multinomial do? Draws samples. Why would this return? Actually, I wonder what probs looks like. Probs is this. Oh no, so this is probs. Okay, I'm sorry. I didn't actually run the next move. So I'm right next command. I want to run this, and now the array Okay, it's got two ones, so I think it just drew two samples. Now how do I get it to be? If I do that, will I get a size 1, 0, 0, 1? What? Let's look at the code here. Take an experiment with one of p possible outcomes, right? An example of such experiment. Here, let me get rid of this so I can read it. Distribution represents n such experiments. Its values represent the number of times the outcome was I. Right, okay, so that's fine. Now if I want to get the index of the one that was found, okay, this is not the clean. I wish this was a little cleaner, but I can actually just do this. I can do 1, and that should work. No, only integer arrays can be converted to a scalar index. But it's not a scalar index. All right, let me debug it again and see if I can figure out the right command for this. So samples, that is right. So this is now that array with integer values, and it's a 1 where it was, where the move was chosen. So now I want to get the index out. There's a command to do that. The thing I feel uneasy about is there could be a bug at some point where I have more than one, but who cares? That right now it's set to be, I should only get one. So I think I can do .index. So I can do samples .index 1, and that will give me nope. Index of, is that what it's called? I forget these commands. Okay, let's just do Google. So we're looking for get index of 1 in. I shouldn't even have to do this. Okay, so here's the thing, right? I should be able to just look at. So if I say samples equals 1, that should be a bunch of booleans, and then I can be able to look. Why can't I do this? Is it because moves is not? It's not a NumPy array. It's a list. NumPy allows you to do logical indexing. Okay, let me try to find the right command here. So I want to find index of 1 in NumPy. Yeah. Oh, where? That's what it's called. So NumPy where. Let's try this. np.where samples and returns 19. Good. Okay. So where are we? Okay. We're gonna do this. Oh, it's so hard to read when it's in debug mode. Okay. np.where samples. Okay, almost there. List indices must be integers or slices, not tuple. That is so ugly. No, that's not it either. Only, what is happening? I promise we're gonna get to chess soon. Okay, let's see. Why is this problem? What's it complaining about? np.where samples, and then if I get the first entry, it gives me. It's still. Indices must be integers or slices, not tuple. Okay, so where returns an ND array, an array with elements from X where in condition is true and elements from Y elsewhere. Oh, okay, cool. So I can actually I could probably use where directly to get the moves. So I want to go to, I'm just going to say samples. So we're going to say where, shoot, moves, samples, one. I don't even have to say equals one. All right, so let's try that. All right, getting closer. Either both or neither of X and Y should be given. Both or neither of X and Y should be given. Condition XY. XY, condition XY. Returns elements from X or Y. Yeah, X, okay, where is not what I want then. So annoying. All right. Let's see, numpy index of. Argware. Maybe that's what I want. Argware is the same as transpose np on 0, blah, blah, blah. So you get so if you have this thing, this vector, and you say argware is greater than 1, you get the indices of it. Maybe that'll work. Let's try it. So let's just go into debug mode right away. Silly thing is, I don't even, this is me. I don't know if I even need to do this. Well, I guess I kind of do. Okay, so np.arg where, and let's say we're doing samples. What do we get? We get an array. Its size is 1 by 1. So can we index into that moves list now? Can't. Why? Why not? What is moves? Moves is a list. So what's wrong with indexing into? Okay, it's an int now. Let's try this. Got it. Okay. All right. It's a little ugly, but I guess it's because, I don't know, something weird happened where argware can return more than one thing, and so this way we get the smallest one. I don't know. This doesn't seem right, actually. Maybe it should be where. All right, let's check this again. Because is this number what I really want it to be? The index is 13. So samples looks like this. Yeah, it's the 13th entry. All right, for some reason this is correct. I don't know. Okay, finally, it should run. There, it played H4. Terrible move. Is the source online? Yeah, I have a GitHub link on my Twitch profile. I think I put on my Twitch profile. Right now, it doesn't have this learning engine. I just started it today, or like half an hour ago. But it has the Minimax agent. All right, so let's do some let's try to make it set it up to do some learning. So to do that, I want to play a game. And I want to store all the board positions. And I don't know if there's any great way to do this. Oh, you don't see the link? Let me me just check why it's missing. I was gonna put it on the screen, but then you can't copy it, so it's better for me to. Well, I can put it in the chat. Sorry, hold on. That was not. Yeah, every time you open Twitch.tv, it plays like whatever was on the homepage, and then it it auto plays it. Actually, there's probably a way for me to make it not auto play that, but you know what? I'm gonna. I'll post a link later. Let me type it in the chat. Where? How do I do that? Oh, that's why I normally had a chat window open here. This way I can actually see people's usernames. Nope, it's still cutting off your username. Okay. All right. So let's see. Where's my GitHub? No, that's not it. I started on this chess repository, but then I moved to this one. Can I paste? Why won't it let me paste? Alright, I'll just type it. OBS doesn't let me paste text into the chat. Oh, you know what? I think I hide URLs. I can't even type it in the chat. All right, check it out. So my username is Birdie38. That's also my Twitter. I guess it doesn't matter, but that's my Twitter ID also. And it's just the Lead Chess Bot. I think this is a public repo. Is this public? I hope it's public. I've been posting a link on my YouTube page. But yeah, check. Oh yeah, someone started, so I think it's public. Or does that just show that other people forked the original? No, that probably has way more stars. Yeah, so someone started this, so it must be public. Anyway, so yeah, back to let me try to get this to work. So what I want to do is have it play a game. So to do that, I'm going to say... I don't know. I'm running out of time. I wanted to do this until like 9:30 or so. So... But this is a very boring engine. It's just playing random. It'll basically just play with random moves. I'm curious if I run it again, it should get a different move. Yeah, so it's getting different moves. That's good. It's always pushing the pawns. Oh no, okay. I thought it was always pushing the pawns 2 squares, but sometimes it's pushing 1 square. So good. Yeah, so it's just trying random moves. Let's try to make this interesting. So I'll have it play. I mean, it's not interesting. I could just like play against it on Lee Chess, online, but it's not going to be interesting because it's going to be random moves. So let me try to get this to work. So I'm going to have it play itself. That's what I want to do. So I'm going to say. Yeah, I could have it play a weak bot, but right now it really just plays random moves. It doesn't learn anything, so it's just going to be like the most it will not be informative because it will literally just randomly move stuff. And I don't mean like random as in like bad moves. I mean like actually random. Like it doesn't even, there's nothing determining what and there's nothing that makes one move better than another to it. So I'm going to just initiate 2 of these engines. So engine 1, engine 2, we're not going to do move, and then we're just going to alternate back and forth. Let's actually not do 1 and 2. Let's do engine white and engine black. And then we're just going to say while board dot is okay, and okay, so I want to So I guess, yeah, this is going to take turns making moves, but then, so I guess if board.turn equals chess.white, I think is the way to define that. Then we're going to say engine white dot search. Okay, move equals engine white dot search. And I already forgot the commands there, so we have to give it the board, we have to give it a time limit, let's do 1,000, and ponder doesn't matter. I'll just set it to be true. And else move equals, let's copy it. All right, and board.push move, and just if we run that, it should finish. Okay, good. So it actually played a game, but we didn't actually see the move. So I can just print move. All right, that's the game. Let's do it in standard algebraic notation. It didn't like that. Expect the move to be legal or none. We got an illegal move. Maybe. Oh, I see. Yeah, I tried to push a move. I pushed the move onto the board and then tried to get the standard algebraic notation, and that's that's not correct. The program expects to get the notation for the position before the move happens. So that's why. All right. So that's the game log, but that's not really what we care about. Although I think we can actually do some learning. That wasn't that slow. So what I want to do now is I want to save every position from the game. Okay, let's see. Let's save all the positions. So I guess the best way to do that is all right, so these are all the positions that white saw, and we're going to store them here. We're going to say, so if it's white's turn, we're going to say white positions dot append, and we're going to give it the feature vector for the position. Engine dot feature board white and do the same thing for black. It actually doesn't matter which engine we use because the features are the same, but in the future they might be different. All right, so I'm saving all the positions that each engine saw, and the idea is that when it wins, it will try to adjust the weights to. I'm just gonna say weights equals engine white dot weights. All right. And right, I'm also going to do. Shoot, how do I do this? So weights is none, so I have it. Okay, I have it initialized as weights. All right, I'm gonna say that learning black, engine black will also get the same weights, so they're gonna be the same engine. Actually, no, let's not. Let's just have white learn. That way, we'll see if it makes progress, and that's what I'll end the stream with it. Hopefully, making progress. So we're just gonna say let's look at outcome. So I think I don't actually know what the outcome object is. So oh shoot, I want to do claim draw. Oh, but that makes it slow. So one of the annoying things about the Python chess is that it can't handle threefold repetition without it being slightly slower than. How slow really is it though? Okay, that's not that bad. If I turn off the printing, let's see if it how long it takes to play a game. Yeah, it's not that slow. That'll be annoying later on if we need to play a lot of games, but I think it's okay for now. So the outcome is this, and now we're going to print. Actually, I'm just going to do a debug here. So it's going to run. I just want to see what the outcome object is, and then the idea is if it's a win, we want to reward white. Outcome. So outcome is there's something called termination 50 moves. Is it always going to hit 50 moves? It might do that because both players are playing randomly. We might never actually wait. What 50 moves is winner none? Is that 50 moves with no captures? I think that's the rule or something. No, what is the rule? That's really annoying. Well, we'll have to deal with that in a second. I suspect that might not always happen. So instead, it's always termination. I guess winner none. So there's a winner object. So maybe if I can I get, let's see, outcome dot winner. I can get that. Okay. So if outcome dot winner equals white, oops, chess dot white, oh, let's just print some stuff. White wins, else print, oops. And finally print, let's, yeah, draw, okay. Is it always going to be a draw because, oh, black won, okay, good. So sometimes a player will actually win. That's really funny though. Random moves lead to a checkmate. That's, I guess, but I guess it will rarely happen while they're playing randomly, and as they get better, they might start to do it more often. But yeah, you can imagine even in the end game, a draw can happen pretty easily if with this bot, even if it learns well, because it's even if, when you're up material, if you don't know what a checkmate is, you're not going to make a check. You're not going to give a checkmate, right? You're just going to start moving your pieces randomly because you're up material and you're happy. So, but if it properly values the better material, it'll what's the word? It'll win more often than not. All right, so okay, back to my plan. So my plan is to make the black engine not update its weights, and the white engine will update its weights. So I'm just gonna say, so if it wins, then I'm just gonna have it update the subtract the weights for all the positions, all the white positions. So let's see, for position in white positions, and I'm just gonna hard code some hacks here. So I'm gonna say learning rate equals 0.01. We'll just make it small. That's probably too small. Let's make it 0.1, and we're gonna say I'm going to hard code something here. So engine white dot weights 0 equals 1. Engine white dot weights minus equals learning rate. Wait, sorry. This time we won, so we want to reward it. learning rate times position. So this is if you know the machine learning here, I'm basically writing a perceptron update rule, which is a classifier. So I'm basically saying like, oh, we won, so every position we saw, we're going to classify as a winning position. That's not accurate, right? We know that in the middle game, or even especially in the opening, it wasn't really a winning position. In fact, especially with random play, almost none of these positions will be winning. But the idea is that the sort of even positions will cancel out, and so sometimes they'll be winning, sometimes they'll be losing. But then when we can actually identify being up, it will hopefully work, hopefully converge toward what we want. So right in the other direction, when black is the winner, we're going to subtract to try to reduce the score. I'm doing this a lot in my head. It probably is I'm probably introducing bugs. For the drawn positions, what am I doing there? For the drawn positions, I want to and no matter what we do, I always want to project that I want to force the let's do that outside here. So the pawns will always be worth 1. Okay. I think I just want to try. I mean, for the drawn positions, what do we want to do? I guess we want to score them lower. Yeah, let's just say we never want to draw. We want to win, and we don't want. Yeah, we're classifying wins versus draws and losses. So this is just happening once so far. So let's put it in a loop. And so what we're doing, what is this? This is let me just give a new weights are all right. So, and we will let this loop multiple times. We're going to do this here. All right. So if this works, which it won't, but when it works, we'll see if it we'll start with seeing sort of a bunch of wins, losses, and draws, and then eventually the win rate will improve. Actually, maybe let's keep track of the win rate. So wins equals 0, losses, let's just say games. I'm going to count draws as nothing, so I'm just going to I'm not going to count the draws for simplicity right now. Print win rate is all right. So we got to divide by 0 because there's no losses. All right, so that's annoying. Come on. Okay. All right, I'm gonna do a quick hack to. Get around that. All right, so the win rate is 0, and then it crashed. So what happened? New weights. The weights got really huge. And it drew black 1. It drew. This is really hard to read too. It's really hard to read. Yeah, this is definitely from scratch. I'm not using. If I could use a framework, but then it would be a little less fun for me. But eventually, I do want to use like a neural network framework so I can build a more complex engine. But for now, this is like the simplest representation you could do that could possibly win. This might win against a beginner because it knows if it can learn the material value, it'll do better than a beginner, a true beginner. Like once you learn the basics of chess, you probably know the material value, and then you can outplay this. All right. So why did this crash? This is these numbers got too big. So let me keep it from getting too big. So I will maybe learning rate's too big. Oh right, of course. Okay. Did it really never win? It's always draws. Yeah, I guess I better keep track of the draws too. So draws 1. And I'll just say wins, losses, and I guess we'll just say, let's just output that. We can calculate in our head whether it's doing better. So far it's been 1 and 1. 2 and 1. And we can look at the values here. You know what I should do? I'm just gonna output the weights in a more readable way. So pawns, let's just do p equals knight, bishop, rook, queen, king, mate. See if I can do it this way. Oh, you know what? And I want to just. It's still going to be hard to read. There's a way to format stuff in Python. I forget how to do it. Let's see. Oops. Python format. Yeah, we're losing a lot more than we're winning, so I might be going the wrong way. Am I going the wrong way? I think I'm going the wrong way. It's like learning to play the worst it can possibly play. Interesting. Yeah, I know, it's hilarious. It'll be interesting to watch what this is. This, you know what I'm missing is I don't have a way of saving this and then having it play online. But let me just. Okay, you know what? It's also getting late. I really needed to stop. So let me flip it around and see if we get it working the positive way. So I basically I had to subtract. I think this is coming from the. Actually, I don't know why this is happening. It's always tricky whether it should be positive or negative. So, but this should be winning positions, but for some reason we're subtracting. I don't know, or maybe it was just random. Maybe that wasn't actually happening. Oh shoot! I know I was in the middle of writing this. So the formatting. It's supposed to be. So I don't want to do the C format version, but yeah, okay. So it's supposed to be like. Let's try that. So we're doing. There must be a way for me just to pass this in directly. But I'm in fast hacking mode, so this is a little bit embarrassing to write code like this. What is? Why is it complaining? This is expected another parentheses. Okay. Does this run? All right, and then the last bit is I have to make these all like this. That's off the screen. Okay. Hey, okay. So run it. Let's see if we're getting. So now these are the values it has for all the different pieces. I don't know why it prefers negative, so I kind of feel like I need to. Now it's losing every time, so it's not working. Oh, you know what was probably happening? It wasn't actually learning to lose. I think it wasn't learning to lose. It wasn't learning to do anything. I think it was not moving because that I set the learning rate too small. So it was already a losing bot at the beginning, and let's try this. This is gonna increase the learning rate. So now the weights are changing. It hasn't really gotten much signal yet because it's a bunch of draws. It hasn't, oh, won one finally. It's really valuing knights. If I'm reading these weights correctly, it doesn't care about mate, doesn't care about queens. It thinks a knight is worth 50 pawns. But this is how it goes. Now playing, it's like playing like maybe 2 games a second, maybe 1 game a second. That's really slow. That's going to take too long for reinforcement learning to make enough progress. But this, I don't know. It's hard to tell if this is actually working or not. It's still valuing knights. I wonder if there's some problem where oh, and then it crashed when I got too big. So I had to prevent it from getting too big. All right, you know what I'm gonna do? I'm gonna set the. Okay, here's what I'll do. I'm gonna set the weights so that they cannot be above 100. Let's say they can't be above 100. So the weights will always be it's not giving me the options. All right, I think it's see if that works. No, that didn't work. Clip, min, max, out. That's weird. Why is it letting it be negative after I clip it? Well, all right, I'm gonna have to stop for now. It's too bad it didn't get working. It didn't get anything working yet, but the basic structure is here. So it's basically some debugging, And then it might be that my like quick fake reinforcement learning isn't actually correct. But I think it should work in theory, because it's just learning to classify winning, positions that you see on the way to a winning game, and as you classify that, you would just sort of want to move in that direction. That's kind of how humans learn to play these games. Um, so you want to replicate whatever happened in any game that you won, and then yeah, and then if you keep doing that, eventually you'll get better and better. There's a big limitation here, of course, which is that the features I'm using are just the piece, um, the material. But anyway, I gotta get going. So thanks for watching. Thanks for hanging out. Stay tuned. I'll try to do this again soon to get this working.